In this video, we're going to be working out the area of parallelograms. Parallelograms are quadrilaterals, which means they have four sides. And what's really interesting about them is that they have two sets of parallel sides. So here you can see the top side is parallel to the bottom side, and the left side is parallel to the right side. Now have a think about what it means for sides to be parallel. If we extended out this top side and we extended out this bottom side, those lines would never meet. It doesn't matter how far out into the distance that we go. That's what it means for lines to be parallel. They'll also always be the same distance from each other. Now, how is this shown normally for parallelograms? So to show that sides are parallel, you would usually see an arrowhead. So here we've got the top and the bottom having one arrowhead. And then because the left and the right are parallel to each other, but not to the top and the bottom, they then get depicted as double arrowheads. Interestingly, if we've got a four-sided shape and we know that two opposite sides are the same length and the other two opposite sides are the same length as each other, we can also tell that it's a parallelogram. So we don't need to be told that the edges are parallel to each other. We could just be told about side lengths. Okay, now let's look at this area formula. So we've got area equals base times height. You'll see that we're no longer talking about length times width like we were with squares and rectangles, but they are related concepts. So what does it mean for us to talk about a base, and what does it mean for us to talk about a height? Well, these two dimensions have a very special relationship, and that is that they're at right angles to each other. Let's say that we were talking about this being the base. The height would have to be perpendicular to it. That is, it would have to have a 90-degree angle between that base and that height. This is the crucial relationship to be able to call something a base and something else a height. Let's see an example of this. So looking at the first shape, we've been given three different measurements. And actually, one of them's the base, one of them's the height, but the third one is actually just another side length. It's really important that you make the right selection in order to get the correct area. So see how we can see a 90-degree angle here? That's telling us that this distance here and this distance here are perpendicular to each other. That tells us that 7 meters is the base, the 9 meters is the height, and the 9.5 meters is a measurement that we don't need. Okay, if we wanted to work out perimeter, absolutely, we would want that 9.5 meters. That'd be very important. But for area, it's important that we actually ignore this. If we use 9.5 instead of 9, we're going to get an area that is too big. So once you've worked out which measurements you're going to use, and we've also checked that they're in the same units, meters, let's start by writing our formula. Area equals base times height. And that's going to be 7 times 9. And that's going to give us an answer of 63. We were working from meters, but because we've gone base times height, we've gone two different meter measurements. We've actually gone meters times meters. So we're now working in meters squared for area. Anytime you work out an area, you're going to want to put a squared sign on your units. Next up, we've got this one here. So you can see we've got two measurements, and because there's a 90-degree angle here, and because we know that this is a parallelogram, there must also be a 90-degree angle here. And because we know that this side length and this side length are the same, it actually means that this bottom side length is 43 millimeters. Now, the reason I've put this example in is because I want you to see that even if we didn't know this here, we could call this the base and we could call this the height. And it doesn't matter that the base is sitting at the top. When we're working out areas of shapes, we're just looking at the relationship between the two different dimensions. It doesn't matter if it's physically at the top or the bottom. We can still refer to it as the base. Now, looking at our units, we've got centimeters and we've got millimeters. So let's change this one in millimeters and turn it into centimeters. So we know that that will mean we need to hop the decimal point over 1. And we are actually talking about 4.3 centimeters along there. Again, always write out your formula. part of the reason for this is it really solidifies the formula in your mind, but it also means if you make an error, you've shown somebody that you know what formula you needed to use, and often you can get partial marks even if you don't get the correct answer, because we are looking at your thinking. Alright, so the base, let's call that one the base because it is a side length, so we generally say that, although it really doesn't matter which order we put these in. But 4.3 for the base and 2.6 for the height, which will give us an area of 11.18, and we're working in centimetres, not millimetres, so just always be careful because we do have millimetres here, but we were working with centimetres, and we're looking at area, so it's squared. Have a look at this next example and pick out the two side lengths that you would use. Hopefully you chose, because we've got the right angle, you chose 4 kilometres and 6 kilometres, and you're ignoring that one. So again, formula, substitute your numbers in, write your answer, and make sure you put kilometres with a squared sign on it. This last example might look a little bit strange because we can see a measurement that's sitting outside the parallelogram. But notice we've still got this 90-degree angle sign here. And what I want to show you is the distance from here up to here is the same as the distance from here up to here. It's the same as the distance from here up to here, from here up to here. So the fact that this sits outside the parallelogram is not a big deal. So don't let that confuse you and make you think that you can't use this measurement. So we'll call this one the base and we'll call this one the height, but we've got one in meters and one in centimeters. So let's change 800 centimeters into 8 meters. Again, you know the drill. Giving us our final answer of 28 meters squared. So hopefully now you feel confident working out the area of parallelograms. Please make sure that your base and your height are perpendicular to each other. Please make sure your units are consistent, and also make sure you're writing out your formula before you go ahead and do your calculation. Lastly, don't forget to put that squared sign on your answer. And thanks for watching.